Good evening, class. We are looking at practice test number 2, which covers chapters 3 and 4. Chapter 3 is about functions and chapter 4 linear functions. So we're going to move on with some of the previous chapter, namely chapter 3 and the new chapter, chapter 4. So let's discuss extrema and their definition. Local or relative extreme value. Extrema is the plural of the Latin extremum. A local minimum is the minimum value within some open interval. Local minimum occurs at a point C in the open interval of A to B in the domain if f of C is less than or equal to f of x for all x values in the open interval. So if you look at this one, the idea is these peaks and valleys are considered local extrema. So this one within some interval is the smallest value. As what do we mean by the smallest value? We mean the smallest y coordinate. So this point represents the location of a local minimum. This, by the way, is the local maximum. So a local maximum is the maximum value within some open interval. Local maximum occurs at a point in an open interval of A to B. In the domain, if f of c is larger than or equal to f of x for all x values in the open interval. So as I mentioned, for example, local mean, local max, local mean, local max. Absolute, also known as global extreme value or extrema, or either maximum or minimum points on a curve. If they simply the word minimum and maximum is mentioned, they mean absolute. Absolute minimum occurs at the point C if f of c is less than or equal to f of x for all x values in the domain. Now, the difference is this happens in the entire domain. So, for example, when you look at this one, local mean, local max, local mean. This one is both local mean as well as absolute mean. Why is this the absolute minimum? There is no point on the graph which has a smaller y coordinate. Absolute max or maximum occurs at the point C if f of c is larger than or equal to f of x for all x values in the domain. So when you look at this graph, local max, local mean, local max. This one is also considered an absolute max because no other point has a larger y coordinate in the entire domain of the function. There's something called the extreme value theorem. If f is a continuous function whose domain is a closed interval of A to B, then f has an absolute max and an absolute mean on the closed interval of A to B. All right. We are going to look at this very simple example and estimate the intervals where the function is increasing, decreasing, and so forth. The graph is given, as you can see. So let's look at some definitions. A function f is increasing on an open interval I if for any choice of x of 1 and x of 2 in I. With x of 1 being less than x of 2, we have f of x of 1 less than f of x of 2. On the other hand, if we have the same situation, but this time when x of 1 is less than x of 2, it results in f of x of 1 being larger than f of x of 2. It's called decreasing, and a function is f is constant on an interval I if for all choices of x, the values of f of x are not changing, they're all equal. A short version of this for the first part, when x value gets larger, so does the y value. If both of them get larger, that means increasing. On the other hand, if gets larger, but y gets smaller, that means must be decreasing. It's that simple. So when we look at this function, we want to estimate whether the function is increasing or decreasing. Okay. I hope you see this is the local max, this is the local mean. So it's increasing. So when we get to local max, it drops to decreasing. When we get to local mean, it goes back up to increasing. So therefore, we are going to write it's increasing here. So what is that? -8 to this one is -3. From here is +3 to here, which is 7. Now, please understand, you really have to use parentheses because the endpoint, we don't know what's happening. In some texts, including mom, they may include the endpoints, okay? So -3 may be included, 3 and 7 may be included, and that's fine. But understand, this is the way we should really do it. As far as decreasing is here. So from here, -3 to +3. And again, I like to use parentheses because at the end points, what's happening? Is it increasing or decreasing? When it goes up there, for a moment, it stops to be both. It's neither increasing nor decreasing. That's why I do not include the endpoints. But if you see that, that's okay. For the sake of exam, you can let me know, and I give you full credit if you do it the way I'm asking you to do so. Determine any local max or mean. Well, obviously, this is a local max. Now, what is that equal to? The y coordinate is 50 at x equals -3, or this pair. The way they ask you, you have to answer it accordingly. The way I like to see, if it were a written exam, you would write local max equals this one at x equals -3, or this pair. What about local mean? Would be here. Okay, seems to be -50. If you said it -50, I don't know, 5, then I have no problem with that. I read it as -50, and it takes place at x equals 3. Okay, this is the point. It's about reading, okay, class, it's about reading. Determine any absolute max or minimum value. So because it stops here, if it continues indefinitely, there is no absolute max. If this continues indefinitely, there is no absolute. But it stops here. So the absolute max is this value, 150. At what point? Roughly 7. Okay, if you read, let's say 7, I don't know, 6.9, I have no problem with that. So that would be the absolute max. Okay. Absolute mean, again, because we have a solid dot and it's right here. As you can see, that seems to be like in between, maybe here. So -225. If you read it differently, I have no problem with that. And the x coordinate is about 8. Okay. And -8, my apologies. And that's fine. Again, it's about the way you read it. Normally it's easier to read than this. All right, we want to find the f inverse, the inverse function, and what is the process. Number one, we're going to change this to y because it makes life easier. That's the only reason. Number two, we are going to interchange x and y. And at this step, we do have the inverse function. However, we don't leave it like that. We solve for y, which means we're going to move the 7 and we're going to divide by 2. Now, this is the inverse function, and we use the notation f inverse x. This is not f to the power of -1, f inverse of x. This is how you read it, f inverse. This is read f inverse. Okay. We are done. However, it's a good practice to check. And to check, I hope you know that f of f inverse equals f inverse of f equals x. So we are going to look at one of them. You can do this or that. We're going to do one of them, and you can check the other one. So if I want to go with f of f inverse, that means into the f of x, you replace the x with f inverse. So 2 times this minus 7. Of course, these two cancel each other. X plus 7 minus 7 is x, and it checks. So pretty simple. We want to find this inverse. We go through the same process. Number one, we are going to call this y to make life easier. Number two, we're going to change this to x and this to y. So x and y are interchanged. So y will change to x, x will change to y. And again, right here, you do have the inverse. However, we are going to solve for y, which means I'm going to do the cross product. I'm going to multiply this two, and I get xy plus 2x, and I'm going to multiply this two, and I get a y. Remember, I want to solve for y. Since I want to solve for y, I'm going to move this to the right and make it minus xy. I'm solving for y, so I'm going to factor the y on the right side. I'm going to divide everything by 1 minus x. So the left side becomes 2x over 1 minus x, and the right side is just y. And I'm going to change the name of y to f inverse. Now, what I want you to notice is that this is the answer, and you're done. If over here you move things differently, that means you move this one this way, this one this way, you could have got this answer. Please understand, if you multiply the top and the bottom by -1, you get this. The difference is this has less negative values than this negative sign than this one. That's why I like this better, but they are both identical. Take a look at it. If you multiply this one by negative, becomes -2x. This one becomes -1 plus x. All right. Now, let's prove we haven't made a mistake by looking at their composite function. Let's look at f of f inverse, which means this is f, replace the x with 2x over 1 minus x. So you replace this one, and you replace this one. Okay. And this is a complex fraction. The fastest and easiest way to get rid of the complex fraction, you multiply the top and the bottom by LCD, the least common denominator for all. And as you can see, 1 minus x is the denominator for the top fraction, and for the bottom fraction, let's multiply everything by that. That means multiply the top by 1 minus x and the bottom by 1 minus x. Now, clearly, when we multiply these two, it's very simple. This cancels out this one. So the numerator becomes simply 2x. But what happens to the denominator? When you multiply these two, you are left with 2x again. And then when you multiply these two, we are going to write it to make sure we understand how to simplify it. Now, of course, this is 2 minus 2x is to cancel each other. 2x over 2 becomes x. Check marks, and we are fine. Here's the function cube root of x minus 1. Here's the function x cubed plus 1. So f of x is cube root of x minus 1. G of x is x cubed plus 1. And we want to use function composition to verify the two are inverse functions, which means we are going to use f o f inverse. In this case, we're going to use f o g because one of them is called f, one of them is g. If their composite function is x, that's a proof. So if I, and by the way, you can do that one or f inverse o f. We're going to do one of them, f o f inverse, which means we're going to replace this x with x cubed plus 1. So we're going to show that, right? So f o g of x means the x must be replaced with the g function. So obviously, 1 and negative 1 cancel each other. And cube root of x cubed is x. Checks. We are done. Since this is simple enough, I want to show you the reverse process. In other words, GOF as well. Because either FOF inverse is X or F inverse OF. In this case, GOF is X2. So I'm going to do that because it's simple. All you have to do, put this one instead of X. So when you raise it to the power of 3, the cube root and the power, they cancel each other. It comes out as X minus 1. And it checks because also the answer is X. Sketch the inverse of the function whose graph is given. Well, we can draw the line y equals x and reflect the graph on the line. How do we do that? I want to make sure we understand this. In other words, you can draw the line y equals x, and then reflecting on that line means what? Well, means I need to find a few easy points. So I'm going to show you this reflection is through finding easy points. So let's pick up a couple of points that we can get from the graph for sure. For example, we know this point is easy because it has the coordinates -2, -4. So if -2, -4 belongs to this function, and we're going to call it the function f of x, by definition means f of -2 is -4. That's the meaning of it. And according to the inverse function, then f inverse of -4 is -2. And simply put, -4 comma -2 belongs to the inverse function. So whatever this pair is, interchange x and y, and this pair negative 4, comma, negative 2. So negative 4, comma, negative 2. This point belongs to the function that we want to graph. So we got 1 point. We're going to pick more points. And by the way, I'm going to go with the easy points. You can choose even more points. Look at this point. The y-intercept is located at 0, 4. That means 0, 4 belongs to f of x, which means f of 0 must be 4. Which means f inverse of 4 must be 0. Which means 0, 4 results in 4, 0 as a point for f inverse. So the y-intercept for f of x corresponds to x-intercepts for f inverse of 4, 0, which means 4, 0. We got one more point. So this is 1 point, this is 1 point. So corresponding, see, if we have this line, see, okay, this line y equals x. Okay, the idea is that, by the way, this distance is the same as this distance, okay? And now this distance is the same as this distance. That's how you get to the other. Just as an example, I hope you see the concept. Let's see if we can pick another easy one. This one seemed to have -1, 3 as its coordinates. So if that's the case, this means f of -1 must be 3. And the inverse means f inverse of 3 must be -1. So if -1, 3 belongs to f of x, 3 -1 must belong to its inverse function. So we locate 3, comma, -1. So this 1, 2, 3, this is 1. So here, and again, I hope you see that this distance is the same as this distance. Now let me use it. Again, if you go with this distance, is the same as now this distance. I hope you see the symmetry. Now again, on purpose, I chose easy numbers we can read. Okay. And so you may need more points, you may not, okay. But the idea is that you can connect this just the way this one is like that, okay. This goes like this, okay. Again, you can pick another one if you want. Again, just for the sake of argument, what you can do, let me just, if you pick any point, let's say you pick this point and you go the same distance, okay, you get another point there, okay, as long as you go the same distance. If you pick this point, okay, drop a perpendicular and go the same distance. That's how you find that. You can pick this point and you go the same distance. Okay. So those are the graphs. These are the pairs that they correspond to each other. All right. This is a piecewise defined function. Sketch the graph of the function f of x, evaluate a few points, and determine the domain and range. Now, If we were to just stick with points, let's say -1, 0, 1, 2, 3. I want to show you how you evaluate them quickly. The function f of x is equal to this. That means y equals -x plus 1 in this vicinity. F of x is equal to that at 1. That really means, this means the pair 1, 2. I want you to know that. So we already have this one. Okay. And we use this function y equals x squared as long as x is larger than 1. So for example, for -1, we're going to use this. And by the way, beyond -1 on the left side, there is nothing. So at -1, if I plug in here, I get +1 and 1 is 2. 0 is in between. So if I put 0, I get 1. 1, I get -1 and 1, 0. I said for 2, we have, for 2, by the way, 1, my apologies, 1, it's not equality, 1 is equal to 2, we already have that. And for 2, we go with this one, which makes it 4. For 3, we go with this one, which makes it 9. If you were to, I mean, you can plot those pairs and you have an idea. But the better methodology is to understand this is a piecewise defined function. You cut it into so many pieces and you start with the top one and you say, okay, the first one is simply a line, y equals -x plus 1, okay? And the intercepts are 0, 1, and 1, 0. If x is 0, y becomes 1. If y is 0, x becomes 1. And you can locate them on the graph. So if this is 2, that means this must be 1. So this is 1, 0. This is 0, 1. Connect them, and you have this line. What I'm going to do for now, I'm going to just draw the line. I'm not going to pay any attention to that. I just want to show you how that thing is going to work. The next thing is the pair 1, 2. So this is 1, this is 2. And the last thing is y equals x squared. It's a parabola. Now, how do we put them together? And this is what I want you to pay attention to. This works from -1 to 1. So at -1, we are here and we have a solid point. At 1, for this one, we are here and we have a hole because it doesn't have an equality. So this is the portion. So this line segment, this is a solid point because of the equality. This is a hole because the equality ends there. There is no equality. Where does this start? It starts at 1. So that means at 1, it starts here, but it's a hole there because at 1, it is not included. So if you plug in 1, you get 1. So 1, 1 is here, and you put a hole there, and the rest of it. You put a hole there. Why is there a hole? Because we don't have the equality, and the rest of it, it continues. Now, that means the following graph. So this whole line, we have a portion of it. The left endpoint is included. The right endpoint is not included. This parabola, we have it from here to infinity, and the beginning is not included because we have 1, 2. Now, what is the domain? I hope you see that from here, -1 all the way to infinity is covered. And -1 has a solid point, so it takes a bracket. The range, it starts from down here and goes up. Everything from here to here is covered. Now, the only thing is 0 covered? Notice this is a hole. So 0 is not covered. Everything from 0 to infinity is covered except the 0. So you put parentheses for both cases. We want to find the average rate of change of f of x equals x squared minus 3x from 2 to 4. Again, the same thing that we've discussed. If we go with this one, that means f of 4 minus f of 2 over 4 minus 2. And this is the function. So plug in 4, we get 4 squared minus 3 times 4. Plug in 2, we get 2 squared minus 3 times 2. Please understand, this is 4 squared minus 3 times 2, so on and so on. So what this is, 4 minus negative 2, the top is 6, over 2 is 3. For the second part, we are going to use the same function, but now from 4 to 4 plus h. So we want f of 4 plus h minus f of 4 over 4 plus h minus h in essence. So what happens is that, please understand, the denominator becomes h because it's 4 plus h minus 4. That's why you have only h in the denominator. Now, we're going to put 4 plus h. That means 4 plus h squared minus 3 times 4 plus h. F of 4, we already know it's 4, but if we were to evaluate it, we put 4 squared minus 3 times 4. Now, I hope you know this is 16. Then 4 times h times 2 is 8h plus h squared. This is minus 12 minus 3h. Minus, we can simplify this or just write it minus. This is 16. Remember that. This is 16 minus 12. I like to distribute and show you why I do that, because clearly these two now cancel each other. These two cancel each other. And then what you have in the numerator is h squared. And these two add up to 5h. You can factor the h out from the numerator and h from the top and the bottom drop. You end up with h plus 5 as the final answer. We are going to move on to linear functions. We want to find the value of x if a linear function goes through the following points and has the following slope. So the pairs are x comma 2 minus 4 comma 6, and the slope is given. So basically you find the missing x using rise over rho. Reminding everybody of lines again. Standard form, ax plus by equals c. Slope-intercept form, y equals mx plus b. Point slope form, y minus y1 equals m times x minus x sub 1. Vertical line, x equals a, and m is undefined, x-intercept at a0. Horizontal line, y equals b, m equals 0, y-intercept is at 0, b. Parallel lines, they have equal slopes, different y-intercepts. Perpendicular lines, the two slopes are negative reciprocal. There are different ways of looking at it. One easy way, their product must be negative. So with that being the case, we are going to use the slope. The definition is rise over run, or y sub 2 minus y sub 1 over x sub 2 minus x sub 1. And with that being the case, m is 3, y sub 2 minus y sub 1, 6 minus 2, and then x sub 2 minus x sub 1 would be minus 4 minus x. Just make sure you don't mix up their order. So now all we have to do, cross product. Obviously, we know this is 4. If I multiply this, I get 3 times that, and then 1 times 4 is 4. So we distribute, we get negative 12 minus 3x on the left. We move the negative 12, we get 16 on the right, and division by negative 3 results in the value of x being negative 16/3. Consider the scenario: a town has an initial population of 75,000. It grows at a constant rate of 2,500 per year. Find the linear function that models the town's population P as a function of the year T, where T is the number of years since the model began. It's very straightforward. Let me just do some explanation as to what's going to happen. We are going to use y equals mx plus b. In this case, we're going to use P to represent the population, mt to represent time. P of t is the population as a function of time. M is the constant rate of growth of the function, which is 2,500 per year. 2,500 per year. So that's M. T is the time elapsed in units of years. B is the initial population. 75,000 is, remember, the y-intercept. In this case, the p-intercept. So, simply put, replace the M with 2,500, B with 75,000, and you're done. That's all there is to it. Monthly cost of a cellular plan depends on the number of minutes used and a flat fee. 410 minutes is going to cost $71.50. 720 minutes will cost $118. Express the cost C as a linear function of the monthly minutes used X. So we are going to use minutes versus cost. Cost is a function of minutes, X comma C. Now here's the two pairs. X is the number of minutes, so 410 minutes is 7150. 720 minutes is 118. So those are the two pairs. Practically, we are done. When two pairs are given, we can calculate the slope and then the equation of a line. So recall the slope is y sub 2 minus y sub 1 over x sub 2 minus x sub 1. So we are going to say c sub 2 minus c sub 1 over x sub 2 minus x sub 1. So 118 minus 7150 over 720 minus 410. And we do the math. 118 minus 71.5 is 46.5. 720 minus 410 is 310. It simplifies to 3 over 20 or 0.15. You can use either way. Both of them are exact. Normally, when you go from decimal to from fraction to decimal, may not be. In this case, it is. Y minus y1 equals m times x minus x sub 1. So we're going to say c minus c1 equals m times x minus x sub 1. So this doesn't change, but this one, let me put it at top here. So we are going to write c minus c1. So you have to use one of these two, not both. So any of it, for either c minus 118 is m, this one or this one, times x minus 720, or c minus 7150 is m, this one or this one, x minus 410. Because this has a decimal, let's use this one. Not that it matters. I'm going to keep it as 3 over 20. Because when we multiply these two, it's fine. When we multiply these two, 720 divisible by 20, we get 108. And if we move this and make it positive, you get this one as the cost function. Or you can use 0.15x plus 10. Either way is fine at this. What is the cost using 687 minutes? Put it right here, 687. And do the math, it ends up being $113.05. Interpretation of the slope and the c-intercept, the y-intercept, now we call it the c-intercept. The c-intercept represents the fixed monthly cost, flat fee charged by company, $10, meaning whether we use the phone, whether we use any minutes or not, it doesn't matter. We have to pay that. That's a fixed cost. So the y-intercept, in this case, the c-intercept is the fixed cost. Okay. Now, the change in cost, the change per minute, is the slope. The slope represents the change in cost per minute of call for the amount of 0.15 per minute, which means every minute that we use, we get charged 0.15. So 1 times 0.15 for 1 minute, 2 times 0.15 for 2 minutes, 10 times 0.15 for 10 minutes, plus this fixed cost is not going to go away. In other words, even if we don't use it at all, we have to pay this much. Okay, when we use it, this much plus 0.15 plus the amount of usage. The height in inches of a sunflower X weeks after being planted can be approximated by the function f of x equals 6x minus 1/4 x squared. How tall is the sunflower 8 weeks after planting? Just plug in 8. That's the meaning of it. So x is 8, everybody. This means x is 8. Plug in. We want f of 8. So this is for the 8. This is 64. You have to multiply it by 1/4 or divide it by 4. It's the same thing. Becomes 16. The difference is 32. And the units of the height, inches. Find the average rate of growth from the end of the week 6 to the end of the week 12. So basically, rise over run. F of x sub 2 minus f of x sub 1 over x sub 2 minus x sub 1, or f of 12 minus f of 6 over 12 minus 6. That's what we are looking. So into the function goes 12 and then 6. So 6 times 12 is 72. This is 144. Divided by 4 or multiplied by 1/4. Makes no difference. It's 36, so minus 36. Obviously, this is 36. This is 36 with the 1/4. That is division. 36 divided by that becomes 9. So we have those. So if I were to rewrite this, it's easier if I do it this way. 72 minus 36 minus 36 plus 9, because this one and this one and this one cancel each other. We get 9 over 6, or 3/2. What are the units? The units of the top over the units of the bottom. The top would be the units of the height, inches. The bottom would be the units of the time in weeks. From module 1, I hope you remember this question. A fitness club charges $20 as a monthly access fee and $2 per day of use. Express monthly cost C in terms of daily usage. We let X be the number of days. Y equals MX plus B. In this case, C of X is MX plus B. And this is a access fee. This is a fixed fee. This is the y-intercept, or in this case, the c-intercept. This is the fee that changes per day. So C of X is 2x plus 20. And for 15 days, 2 times 15 is 30 and 20. They will charge us $50.